All right, so I'm going to look at um, talking about solving uh, absolute value equations. In this case, I'm going to stick with linear, but the approach we're going to look at can be applied to any absolute value equation. Just the details get a little bit more complex if they're not linear. So what we want to do is start off by looking at kind of a simple example here. Um, so let's say the absolute value of some number is 6, and we want to know what is that number. Well, from our basic understanding of how absolute value works, we know that if you put a 6 in here, the absolute value of it will give you 6, so 6 is a possible answer. The other possibility is you could put a -6 in here because absolute value just gives you the size of the number inside. So the size of -6 is 6 units. So that would also give you um, 6. And what we see here is we get one of these equations, one of these answers looks like this exact same thing, just without the absolute value bars. And then we get a second one that the inside part is the same, but the outside part becomes a negative. And so if we kind of follow that pattern here, let's say we had the absolute value of 2x minus 1 equals 11, then again we could say, well, without figuring out what x is directly, we can say whatever's inside here, this statement, this 2x minus 1, when we do that calculation, whatever that is, it has to come out to be 11, or that calculation in there has to come out to be a negative 11. So that when we take the absolute value of that, we'll get 11 as an answer. So if this inside part sorry, is equal to 11, then if we were to solve this, 2x equals 12 divided by 2. So one possibility is x could equal 6. Alternatively, if 2x minus 1 equals negative 11, then add 1, you get negative 10 divided by 2. So x could be negative 5. And both of those would give you. So what we're seeing is this pattern, this where the inside part here, this inside part equals the outside part, or it equals the opposite of the outside part. So inside part, and then the outside part, or the opposite of the outside part. And now, in order for that to make sense, we do need to make sure that we get the absolute value by itself first. So let's say we want to do 3 minus 5 absolute value of x plus 4 equals negative 12, let's say. So what we need to do first is get rid of that 3. So negative 5 times x plus 4 equals negative 15. Get rid of that negative 5. So absolute value of x plus 4 equals 3. Then set up our two props that x plus 4 could be equal to 3, or x plus 4 could equal negative 3. And then subtract 4. So x could equal negative 1. Subtract 4. X could equal negative 7. Okay, so you got to get the absolute value by itself, and then you set up these two problems. You split this up into two problems. One looks exactly the same without the absolute value bars, and then the other one, we change the sign of the outside part. Now, let's step it up and make it a little bit more complicated, perhaps. So let's say I have 5x minus 7 equals negative 8. And I say I want to solve that. Well, the answer is no solution. Why? Well, absolute value tells you the magnitude of the size of the number, and the smallest that can possibly be is negative. So there's no way this answer can be a negative 8. So as soon as I see that, I immediately should say, oh, okay, no solution. Now, if we jump back and we look at this previous problem, notice this was a negative 12 at the beginning, but when I worked it all out and I got the absolute value by itself, I had a positive 3. So I knew this was going to give me some solutions because it was equal to a positive. On the other hand, on this example, I had an absolute value equal to a negative, and so I knew that wasn't going to be any solutions. So, if the other side is positive and you have an absolute value by itself, then it should have answers, and if it's negative, then it shouldn't have answers. When it gets really tricky is when you want to solve something like 3x plus 1 equals 6 minus 2x. And the question is, does this have answers or does it not have answers? And the answer is, I don't know. I have no idea yet if this has answers or not. What I need to do is I need to act like it does, because I don't know if this outside part is positive or negative. It depends on what x is. If x is, let's say, 1, then this is 2 times 1, which is 2, so 6 minus 2 is 4, that's positive. That would have answers. On the other hand, if x is like 5, this would be 2 times 5 is 10, 6 minus 10 is negative 4, that doesn't have an answer. So I don't know what it is yet. I have to work it out. So what I'm going to do is I'm going to approach this as if it was. So I'm going to get one problem where I have the inside part that's just going to equal the outside part. Or I'm going to have a problem where I have the inside part and it's going to equal the opposite of the outside part. This is going to be negative 6 plus 2x. And I'm going to work those out and see. So let's say I want to add 2x over here. Get all my x's on one side. 5x plus 1 equals 6. Subtract 1. So 5x equals 5. Divide by 5. So x equals 1. Now, is that an okay answer? Well, let's see. 2 times 1 is 2. 6 minus 2 is 4. That's positive. So yeah, that answer is fine. Okay. Let's say I do here. Again, I'm going to get my x's together. So in this case, I'm going to subtract 2x. X plus 1 equals negative 6. Subtract 1. X equals negative 7. Is that okay? Well, negative 2 times negative 7 is positive 14. 6 plus 14 is a positive. So yeah, that worked. Now sometimes in a case like this, you'll get, like I got here, maybe 2 answers. Or maybe you'll get one answer, one of these will work, the other one won't. Or maybe you won't get any answers. Think about if this problem had instead been 2x minus 6, this would have been no solution. There would have been no way to make that work. So you don't know until you get those answers, and then you can verify if those answers work. You'll notice one of these answers is positive, one is negative. It's not an issue about whether they're positive or negative themselves, but what do they do to the outside part? Do they make the outside part positive or negative? All right, so that's solving absolute value equations. And again, these were all linear, but you can see if there was an x squared in here, you could work that out and solve it and do it likewise. All right, thank you.